This is Sedna, and Sedna is an ice ball out in the distant solar system. This picture was taken in 2003 with the Hubble telescope. And this is an artist's rendition of Sedna. You'll notice that it's red, and that red is caused by what are called tholins. Tholins are basically long chains of carbon that have different little elements sticking off of them, like nitrogen or sulfur. Basically what happens, you have a whole bunch of methane up on these objects. The objects are basically made out of frozen methane. And when that methane gets hit by ultraviolet rays, it can pop off one of the hydrogens, and that frees up space for the carbons to stick together and form long chains. This is Pluto's moon Charon, and you can see up on its pole there, it's got a big reddish-brown spot, also caused by tholins. That spot is called Mordor Macula. Well, this right here is Sedna's orbit, and you can see way off on the side there is where Sedna is. Right there you have the entire solar system, and in fact, Pluto is right there. So when Sedna goes around, it's always outside of Pluto. In fact, its nearest passage to the sun is about 76 astronomical units. For reference, Neptune is 30 astronomical units from the sun. So at its closest, it's 2.5 times as far as Neptune is. And when it goes all the way out over here, it's about 930 astronomical units. So 31 times the distance that Neptune is. And here you can see the plane it's on at the bottom. You can see it's at an angle while the rest of the solar system would be flat, at least the planets would be. Well, this looks similar, doesn't it? But it's not actually the same one. This is 2012 V113, also known as Biden. It's a similar object to Sedna, which itself is similar to Pluto. And you can see it's got a similar orbit, and it's even on a similar plane. Well, Biden was noticed in 2012, but it wasn't really fully characterized until 2014. Well, the astronomers who mapped out that orbit took their findings to a couple of other astronomers at Caltech. Anyway, the two astronomers that data was brought to was Michael Brown and Konstantin Batygin, and they noticed there was a pattern, not just with Sedna and Biden, but with a few other objects as well. And what these objects had in common is that they were at the outer edge of the Kuiper belt. They really weren't part of this chunk of material that's kind of moving around just outside the orbit of Neptune and stretching out maybe to 50 or 60 astronomical units. But they also weren't quite out in the Oort cloud. The Oort cloud, okay, so just for reference, the Kuiper belt would be that little dot there. The Oort cloud goes out like 10,000 astronomical units. Now, the Kuiper belt we know is there. The Oort cloud is kind of theorized, but it explains a lot of observations, so there's no reason to believe it's not there. Anyway, getting back to it, these objects that they noticed, they were outside of the Kuiper belt, but they weren't quite Oort cloud objects. So here are the charts, the orbital charts of the objects they noticed. And there's Sedna right there, and there's Biden labeled up there. But you'll notice that they all come around this same side of the sun, and they all stick out on this far end going toward the Oort cloud. So then the question becomes, how do those objects maintain those orbits? Those orbits wouldn't be stable. There has to be some larger object pulling on all of them. And what they hypothesized is a 10th planet that's pulling on all these objects and nudging them, making those orbits stable. And based on their modeling, they proposed a mass and a potential orbital range for Planet 10. And in fact, as of right now, it's almost certain that there's something out there that's tugging on these objects. If it's not Planet 10, then it's something else. So ever since 2016, they've been looking for this planet, and I'm relying a little bit on this paper, this is a preprint, so it's not the final version, but it was put up on February 1st of this year. So this is a sky map of where in the night sky they believe that planet would be visible. Now, they believe that planet is larger than Neptune and much further out. In fact, hundreds of astronomical units away from the sun. So on their chart here, the red areas represent the places where they believe the highest probability would be, and then cooler areas, bluer areas, would be where the probability is lower. And what they've been using for their search is data from sky surveys. So this telescope is in Chile, and it was used for the dark energy survey. Basically, this telescope is actually looking for voids in the cosmos. But the data can be used to look for objects in our solar system as well. And this one in Hawaii was used to observe the northern hemisphere, and it's also just doing sky surveys. And looking at all this data that's been gathered and analyzed ever since 2016, this is all that's left for places where Planet 10 could be. So the model they created had this probability of where this planet might be observed, and now there's only 22% of the sky left before their hypothesis is effectively disproven. But by narrowing down all these observations, they've also kind of been able to dial in what they expect this planet to look like. So about 6.5 times the mass of the Earth, and for reference, Neptune is 4 times the mass of the Earth, so 2.5 times the mass of Neptune, possibly up to 4.5 times the mass of Neptune, and currently 550 astronomical units away. And 550 astronomical units would be about 51 billion miles. One of the most disappointing things is that it has a magnitude of 22. And to explain real quick why that magnitude of 22 is problematic, the higher the number, the dimmer the object is. And the best instruments that are out there right now generally see somewhere to around 20.5 magnitude. So that magnitude of 22 would make it almost impossible for even something like the Gaia Space Telescope or the Spitzer Space Telescope to even see it. So at this point, astronomers are actually heavily reliant on seeing the motion of other objects around it to be able to pick it up. And over the next couple years, there's going to be data collected by the Vera Rubin Observatory, which they think will exclude the rest of that region. So they give a few explanations about why it might not be findable. There could be different colors. It could have a different ability to reflect light. It's also possible that it doesn't exist. But then the problem is there'd have to be another explanation for the orbits of these distant objects. They also note that it's possible that these objects didn't originate in the Kuiper Belt, that they might have originated in the Oort cloud, in which case there could be a much larger planet that's way further out near the Oort cloud or in the Oort cloud that's actually creating these orbits. And that kind of touches on a paper I looked at last year where these folks looked at the possibility of large planets being out in the Oort cloud. And this graph looks kind of weird, but basically this dark gray was the only planet size based on their modeling that could have survived a trip from the inner solar system all the way out to the Oort cloud. And the mass of that was 94 times the mass of Earth, or about the size of Saturn. Now, I know somebody's going to come at me and say, that doesn't say Planet 10 in that title. Well, it would be Planet 10 because Pluto is a planet. I'll die on this hill.